Hi, he is Carlos Pereira dos Santos.
He is Jorge Nuno Silva.
We are mathematicians and directors of Ludus Association, a Portuguese institution focused on the promotion of mathematics.
Today, we will be showing you the board game Cats and Dogs.
Cats and Dogs is played by two players. The pieces of one player are dogs and the pieces of the other player are cats. In this video, we'll use the famous Felix the cat and Droopy McCool, the dog.
Players alternate placing cats and dogs on the board. Notice that a player cannot put a dog next to a cat or a cat next to a dog, vertically or horizontally.
It is okay to have different animals diagonally neighbors. The board gets increasingly crowded. The first player without any legal move loses.
In Portugal, we organize yearly a huge tournament of abstract board games for pre-university students.
Every year, since 2004, tens of thousands of young people practice mathematical games. We share the organization of this event with the Portuguese Mathematical Society, the Association of Teachers of Mathematics, and Ciência Viva.
A vontade de ganhar aproveita-se, no bom sentido, para este convívio que aqui vê e esta prática de atividades extracurriculares altamente sofisticadas, de grande nível intelectual. São jogos muito bem escolhidos, muito bem concebidos, são os chamados jogos abstratos, os jogos matemáticos, de que os alunos vão beneficiar sem dúvida para o futuro.
Naturally, Cats and Dogs was one of the games in the Portuguese Championship of Mathematical Games.
Combinatorial game theory studies sequential games with perfect information.
Elwin Berlekamp, John Conway, and Richard Guy wrote Winning Ways for Your Mathematical Plays in 1982, the seminal work in this field.
Cats and Dogs is a variation of the game Snort, invented by Simon Phillips Norton, a mathematician from Cambridge, who, with John Horton Conway, made contributions to several mathematical subjects as combinatorial game theory.
The illustrated game occurred in the Portuguese tournament. It was not perfectly played. Combinatorial game theory helps to understand some situations that arouse during the play.
In the position, some squares are not available. We cross them out.
There are 3 squares that are guaranteed moves for Droopy. We mark these with bones.
These are 3 guaranteed moves for Felix. We use fish here.
There is a square up for grabs, still available to both players. We use a ball for that square.
In the actual game, Droopy made a very bad move. He played in his guaranteed zone instead of playing on the undecided square.
This sample situation shows the main goal of combinatorial game theory, to quantify separated parts of the board in order to help understand the global situation.
As expected, Droopy and Felix zones, bones and fish, correspond to 3 moves for each. Here is the quantification. The ball zone is what game theorists call a star.
The position illustrates a result of combinatorial game theory, the number avoidance theorem. Basically, it states that players should not move in their guaranteed areas until there are no other moves available.
Some situations may occur where the players rush to play. We call them hot. In these situations, a single move can ensure oneself a good zone. Let us see an example.
Again, we mark with crosses the forbidden squares.
A move in this square guarantees 1 further move.
A move in this square guarantees 2 extra moves.
A move in this square guarantees 3 more moves.
Of course, a player should prefer the gain of 3 moves.
Combinatorial game theory created a mathematical tool which goes by the name of temperature theory that studies the incentive of a move. Of course, there are many kinds of interesting situations of varied complexity.
The analysis and the insights that arise from approaching those positions with combinatorial game theory tools are part of the shining charm of this great mathematical field.